Swayam Prabha. Digital India. Educated India.
Namaskar. So, in last two sessions we discussed about Z parameters and Y parameters. So, in case of Z parameters we stabilize the relationship for V1 and V2, that is the voltages at the two ports in terms of the currents, while in case of Y parameters we stabilize the relationship for currents at both sides in terms of voltages. Now, third condition may arise when you have voltage and current as a dependent component. Then in that case what will happen? That will give the new set of parameters which we will discuss in today's session. So, let us start the discussion of today's lecture. We will discuss about the hybrid parameters in today's session. So, we have seen Z and Y parameters, but in case of two port network it is not necessary that you will always have a flexibility to find out the Z and Y parameters. There is a need for developing another set of parameters wherein you may have the dependent variables as V1 and I2, while the independent variables will be V2 and I1. So, these kind of relationships you will see mostly in the electronic devices such as transistors. So, in case of transistors, if you have studied, we develop the equivalent model of transistor in terms of H parameters. So, in those cases we can use the H parameter variables which we will discuss in today's session. Now, it is much easier to measure experimentally the H parameters of such devices than to measure their Z and Y parameters. That is why we are more interested into the H parameters calculation. So, if you recollect that we discussed that in case of ideal transformers we cannot create the Z parameters for that circuit, but in this case the ideal transformer can be described using hybrid parameters. Now, how we will define the relationships between the terminal voltages and the currents in case of H parameters? We will say that V1, that is the input port voltage, will be related to input port current and output port voltage in terms of H11 I1 plus H12 V2. Similarly, output port current, that is I2, will have a relationship between input port current and output port voltage, and we will define it as I2 is equal to H21 I1 plus H22 V2. So, these are the two basic equations to find out the H parameters. Now, in matrix form how we will represent? So, you will have a vector which will have V1 and I2 as a component, and then we will have the H matrix, and then the independent variable vector, that is I1 and V2. So, in summary we can say that we can represent it like input the dependent vector is equal to H parameter matrix multiplied by independent vector. Now, H terms are known as the hybrid parameters or H parameters in this case. So, why they are called as hybrid? Because in this case we have a combination of ratios. So, if you see H11, it will be having the relationship between V1 I1, while H12 will have a relationship between V1 and V2. So, when you see these two equations, you will come to know that there is no uniformity in the parameters. These are the hybrid kind of parameters which we have in case of H parameters. Now, how you will how you will find the h parameters. The value of parameters can be evaluated by setting V2 is equal to 0. That means, you set the output port short circuit, or I1 is equal to 0, that is input port open circuit. So, let us take first case in which we set V2 is equal to 0, that means the output port is short circuited. So, if you set V2 equal to 0 in these two equations, what will happen? H11 will be V1 upon I1 and H21 will be I2 upon I1. So, H11 you get V1 upon I1 and H21 you get I2 upon I1. Now, second case is when you set I1 equal to 0. So, here if you set I1 equal to 0, H12 you will get as V1 upon V2 and H22 you will get as I2 upon V2. So, you will get rest of the two H parameters as H12 is equal to V1 upon V2 and H22 as I2 upon V2. Now, these parameters, what they represent? H11 represents the impedance, because it is a ratio between V1 and I1. H12 is the voltage gain, because this is a relationship between V1 and V2. H21 is the current gain, because it is again the ratio between I2 and I1, and H22 is the admittance, because it is a ratio between I2 and V2. So, now since we have impedance, voltage gain, current gain and admittance as a parameters, we will say them as a hybrid parameters. So, now you can say that H11 is nothing but short circuit input impedance, H12 is open circuit reverse voltage gain, because H11 you find when you set the output port as short circuit. So, this is short circuit input impedance, H12 is open circuit reverse voltage gain because it is a relationship between V1 and V2. Then H21 is short circuit forward current gain, and then H22 is again open circuit output admittance. Now, the H parameters you can determine in a similar way as we determined in case of Z or Y parameters, means you can just write the relationships H parameter equations and then you can easily find out the H parameters. In case of reciprocal circuits, H12 would be equal to minus of H21. So, hybrid model of a two port network you can define like this. How you will define, how you will draw this kind of circuit? If you see the first equation which we have, P1 is equal to H11 I1. So, that is H11 multiplied by current flowing through this, and then you have H12 V2, that is dependent voltage source. So, it will become H12 V2. So, this is simply a series combination of the resistor and the dependent voltage source. That is why you define it in terms of voltage V1. Now, here it is a parallel combination. So, you can straight away utilize the nodal analysis. So, if you use Kirchhoff current law, what you will get? You will get I2 is nothing but that is the current dependent current source. So, you can simply write H21 I1 plus H22 into V2. So, these two are the same equations which we represented initially to define the H parameters. So, the same equations you can utilize to draw the hybrid model of a two port network. So, this will be your equivalent H parameter circuit for a particular network. Now, there is another set of parameters which are closely related to H parameters, and what they are called? They are called as a G parameter or inverse hybrid parameters. Now, in case of H parameters, we stabilize the relationship between V1 and I2. So, V1 and I2 were the dependent variables in case of H parameters. Now, in this case, when you are defining the G parameters and or you can say the inverse of H parameters, will have the dependent variables as I1 and V2, independent variable will be V1 and I2. So, now how you will describe the terminal currents and voltages? I1 in this case will become G11 V1 plus G12 I2, V2 will become G21 V1 plus G22 V2. So, this can be another set of equations which will define the G parameters. So, in matrix form how you can write? You can write as a dependent variable vector, that is I1 and V2 equal to the G matrix multiplied by independent variables, that is V1 and I2. So, since if you see these are inverse of H parameters, because in case of H parameters we were having I2 and V1 as dependent variable, here we are having the opposite of that, that is I1 and V2 as dependent variable. So, we will say G as inverse of hybrid parameters, or we say in short as G parameters. Now, how you will find out the values of G parameters? The values of these parameters can be evaluated by now setting V1 equal to 0, that is input port short circuited. So, in case of H parameters we were having V2 is equal to 0, that is output port was short circuited. Here V1 equal to 0 means input port is short circuited, and I2 equal to 0, that means output port open circuit. In case of H parameters we set I1 equal to 0, that is input port open circuited. So, now if you set I2 equal to 0, so if you see the equations, if you set I2 is equal to 0, G11 we will get as I1 upon V1, G21 we will get V2 upon V1. So, we get G11 as I1 upon V1, G21 we get V2 upon V1. If you set V1 equal to 0, then you get G12 as I1 upon I2 and G22 as V2 upon I2. So, you get G12 and G22 again. So, if you now see the parameters, that is G11, G12, G21 and G22, they represent the G11 will represent admittance, G12 will represent current gain, G21 will represent voltage gain and G22 will represent impedance. So, you can correlate with you can compare them with the H parameters, where H11 was impedance, H12 was voltage gain, H21 was current gain and H22 was admittance. So, here you will see the parameters are opposite to what we had in case of H parameters. So, here G11 is admittance, G12 that is current gain, G21 is voltage gain and G22 as admittance impedance. Now, you can say that G11 is now open circuit admittance, G12 is short circuit forward current gain, G21 is open circuit reverse voltage gain and G22 as short circuit output impedance. Now, here also you can find out the G parameters similar to what we did in case of Z or Y parameters. Here the inverse hybrid model, that is the G parameter model, you can draw like this. If you see here, the current source and the resistances are in parallel. So, you can use nodal analysis in this case. So, if you apply Kirchhoff current law here, then I1 will become G11 V1 plus G12 I2, that is the dependent current source you have got. So, this you will get in case of this part of the circuit. In case of second part you will see that the resistance is in series with dependent voltage source. So, you will use Kirchhoff voltage law. So, when you use Kirchhoff voltage law, you will write V 2 as G 21 V 1 plus G 22 I 2. So, now you will see that these two are the same equations which we initially mentioned in case of G parameters. So, these equations can be used to draw the equivalent circuit for G parameters. Now, let us understand these concepts with the help of few examples. Let us take first the example in case of H parameters. So, here if you see, you have the T circuit which has one 2 ohm resistance, 3 ohm resistance and 6 ohm resistance. Now, we need to find out the H parameters. So, we will use the basic definition for in case of H parameters. So, we will first determine the H 11 H 21. How? We will first connect the current source I 1 to the input port and short circuit the output port. So, if you see the updated circuit, here you have the T circuit of the T circuit given in the question. Now, you are making output port short circuit, means V 2 is 0 in this case, and you are applying the current source I 1 to the input port. Now, when you short circuit the output port, this 3 ohm and 6 ohm resistance will now be in parallel. So, what you can write, V 1 is nothing but I 1, that is the current flowing into the circuit, multiplied by the total resistance of the circuit. So, what will be the total resistance? This 2 ohm will be in series with the parallel combination of 6 ohm and 3 ohm. So, when you simplify, you will get V 1 equal to 4 I 1. So, now you can simply find out the value of H 11, that is V 1 upon I 1, and when you put the value of V 1 as 4 I 1, you will get H 11 as 4 ohm. Now, in the second case, what you have to do now, you will utilize the current division at this point. So, if you see the current flowing in this particular segment, that is 3 ohm resistance, will be the current which is flowing here will be divided in 3 ohm and 6 ohm resistance. So, using current division, you can find out what is the value of current flowing in the through this particular 3 ohm resistance. So, what you get using current division, you will get the value of current flowing in this, but here the value of current is also minus of I 2, because the direction of current is opposite. So, you can write minus I 2 equal to 6 upon 6 plus 3, which we got with the help of current division. So, you will say that minus I 2 is equal to 2 by 3 I 1. So, you will get H 21, that is the ratio between I 2 and I 1. So, you will put the value of I 2 in terms of I 1, and when you simplify, you will get H 21 as minus 2 by 3. Now, next what we have to do, we need to find out the values of H 12 and H 22. So, what we will do in this case, we will connect a voltage source V 2 now to the output port, and we will keep the input port as open circuit. So, in this case I 1 will become 0, and we will apply V 2 to the output port. So, what will happen now? So, if you use the voltage division at this particular point, so you will see that the value, that is V 2, is applied across 3 ohm and 6 ohm. So, value of voltage, that is V 1 across 6 ohm, can be found in terms of V 2 with the help of voltage division. So, what we can write, V 1 is nothing but 6 divided by 6 plus 3 into V 2. So, we get V 1 is equal to 2 by 3 V 2. So, you can say H 12 is nothing but V 1 upon V 2, and when you put the value of V1 in terms of V2, you get H12 as 2 by 3. Now, also you can say that V2 is equal to I2 into 3 plus 6, because V2 is applied across this, and there is no current flowing through the input port, that is I1 is equal to 0. So, you will say V2 is equal to I2 into 3 plus 6, that is 9 I2. So, you can simply find the value of now H22, that is I2 upon V2, that is 1 by 9, and this value will be in Siemens, because this is a relationship between I2 and I2 by V2. Now, if you see H12 is 2 by 3 and H21 is minus 2 by 3. So, you can simply say that this particular circuit is reciprocal circuit. Now, next let us try to find the G parameters of the circuit, which is given in this figure. Here you will see that the circuit is having inductor of 1 Henry, capacitor of 1 farad and resistance of 1 ohm. Now, what we have to do? We have to find the G parameters as function of S. So, means that we have to convert first the circuit into Laplace domain, that is S domain. So, first we will convert into Laplace domain, that is we will say that 1 Henry is in S domain, we will say as S, capacitor will be represented as 1 by S and resistance will remain same. Now, to find out the value of G11 and G21, what we will do? We will connect a voltage source V1 to the input port and we will open circuit the output port as we see in this figure. So, here now what will happen? I2 will be 0 and we will have current I1 flowing from the input port. Now, what is the value of I1? I1 you can simply represent in terms of V1 and the other circuit components. So, you will simply say I1 is equal to V1 upon S plus 1, because this voltage will be applied across the inductor and the resistance. So, now you get I1 is equal to V1 upon S plus 1. So, G11 is nothing but I1 upon V1, that means 1 upon S plus 1. Now, next what you have to do? You have to find out the value of voltage V2 in terms of V1. So, you can simply use voltage division here, because V2 is applied across 1 ohm resistance. So, V2 can be represented in terms of V1 with the help of voltage division. So, if you apply voltage division, V2 will be 1 upon S plus 1 V1. So, what is G21? G21 is V2 by V1. So, you will say G21 is nothing but 1 upon S plus 1. Now, next we need to find out G12 and G22. So, for that what we have to do? We have to connect a current source I2 to the output port and short circuit the input port. So, we will short circuit the input port, that means V1 is now equal to 0 and we will apply I2 as a current source at the output terminal. Now, we need to find out the value of G12 and G22. So, what we will do? We will use the current division. Here if you see, the current I2 is flowing 1 ohm resistance as well as in the inductor. So, if you see that the component of current flowing through the inductor, the component of I2 will be nothing but equal to minus of I1. So, what we have to do? We have to find out the portion of I2 flowing through the inductor. So, for that we can simply utilize the current division. So, if you utilize current division, I1 will become minus of 1 upon S plus 1 into I2, because in this case I1 and the component of current I2, that is say I2 dash, will be in opposite direction. So, you will get minus sign over there. So, I1 is now minus of as 1 upon S plus 1 into I2. So, G12 you will simply get I1 upon I2. and that is nothing but minus upon S plus 1. Now, we need to find out the relationship between V 2 and I 2. So, what we will say, what is the value of V 2? Value of V 2 is nothing but the value of current I 2 multiplied by 1 by S plus the parallel combination of 1 ohm and the inductor value having S, because since this is a short circuit. So, inductor and resistance will be in parallel. So, total value of V 2 that will be applied across the parallel combination of inductor and resistance and in series with capacitance. So, you can say V 2 is nothing but I 2 into 1 by S plus the parallel combination of resistance and inductor. So, what we will write? I 2 into 1 by S plus S in parallel with 1. So, what you get now? The final G parameter, which is G 22, that is V 2 upon I 2, which will be nothing but equal to 1 by S plus S upon S plus 1. So, if you simplify, you will get G 22 as S square plus S plus 1 divided by S into S plus 1. So, now whether it is a simple network or if you get the network having resistance, inductance and capacitance, you can easily find out the parameters that may be Z parameters, Y parameters, H parameters or G parameters. So, with this we can close our today's session. In this session we discussed about two important parameters, which were H parameters and G parameters. Thank you.